Hello everyone and welcome back to another project. In this project I'm going to show you the Face ID based smart doorbell including the smart door lock with real-time database, of course including IoT for sure. So it's a computer vision based project. So initially I'll be talking about the features of my project, then I'll talk about the components that I've used here, and finally I will show the demonstration the way the project works. So initially let's talk about the features. So what happens when someone is at your door? He has to click on a button and the doorbell rings out. But I came up with an idea of designing a doorbell that will ring out once a person is in front of the camera that will be set in at the door. Later on, this can be deployed in facial recognition that I'll be showing in one of the later videos, in one of the upcoming videos. But for now, I will be limited within the face detection and the doorbell corresponding that, allowing not proceed to the face recognition process for this part of the project. So what will happen here is if someone is present at the door in front of the camera within the virtual zone defined by me, then the doorbell will keep ringing once in every 2 seconds. That means the control signal or the control strings from the Python script to the ESP32 board will be sent once in every 2 seconds. And after that, after verifying if the person should enter or not, or after ensuring the fact whether someone who is resident in the house wants the door to be locked or unlocked, it can be unlocked simply by pressing on this button or by using the IoT cloud server. So I have kept both of the options, the cloud-based operation as well the manual button-based operation to unlock the door. And as soon as the doorbell has rang out, the person that was at the door, his snap will be saved in the local device. As well, the snap will also be sent to Telegram to the corresponding person, maybe to the owner of the house. And the information whether the door was locked or unlocked will be logged in a real-time database in an Excel sheet, and the Excel sheet will keep updating as the person comes in with time at the door, I should say. So that's all about the features, and there will be an IoT cloud server. For example, I have used the Arduino's IoT cloud from where the door can easily be unlocked. As well, we can also monitor the state of the door lock and check if there is any kind of bills. So this is the way to control the lock remotely, in a bit smarter way, I should say. So I believe I'm done with the features of my project, and it will be clearer once I will dive into the demonstration. But for now, let's talk about the components that I've used here for deploying the project. So as usual, as the microcontroller, I have used the ESP32 board. I believe you can see this. I have used the ESP32 board as the microcontroller that comes with a built-in Wi-Fi. So it will allow me to connect with the internet and do the cloud-based operations and control the loads remotely from any corner of the world simply by using the cloud server or simply by using an Android application. As the electric lock, I have used the 12-volt solenoid electric lock, and as you can see, to run the 12-volt solenoid electric lock, I required a 2-channel 5-volt relay module, and to alert that someone is present at the door, I have used a small buzzer that will start buzzing once in every 2 seconds if a person is present at the door, and it will keep buzzing as long as the person is present. I also have a bulb over here, the red bulb. I believe you can see that quite clearly. Let me try to annotate it for one more time. So here is the red bulb that I've used that will be flashing in synchronous to the buzzer as long as the person is present at the door. And of course, this is an AC load which is powered with 220 volts AC from my household outlet, and this is a 12-volt solenoid electric lock. But the small control signal generated by the ESP32 board are not sufficient enough for driving these high voltage loads. So in order to switch these high voltage loads with the small DC control signals generated by the ESP32 board, I have used the 2-channel 5-volt relay module. As you can see, It's a 2-channel 5-volt relay module that switches at DC control signals of 5 volts. However, the ESP32 board generates control signals at 3.3 logic levels. I have checked that the relay module is suits enough, 3.3 volts. It can switch the loads even at 3.3 volt control signals. So that's a good part of using the 2-channel 5-volt relay module. You don't need to use any boost modules or 3.3 to 5 volt logic level shifters. And I have a touchpad over here using which you can unlock the door from inside simply by touching on this button. And to power the relay module comes with 5 volt power. So to power it, I have used this let me annotate. I have used this pair of batteries. Each of these are 3.7 volt lithium ion batteries, and altogether they will be generating around 8 volts, which is excess for the relay module. So I have to step it down. I had to step it down using this LM7805 linear voltage regulator, and then the output of this linear voltage regulator, which is 5 volt, has been fed to the relay module. As I'm using inductive coils over here, loads having inductive coils inside, there is a solenoidal coil inside the door lock. I have checked it. I have opened it once. So once the load is energized or de-energized, there is a phenomena of flowing reverse current through the circuit. So that may hinder the operation of the microcontroller or even may cause damage to the other components. So to avoid to prevent any kind of reverse current, I have used here a flyback diode which has been connected opposite to the polarity of the load. So this flyback diode or the fueling diode prevents any reverse flow or backflow of current, ensuring the smooth operation of all these devices. And these 3 lithium ion batteries have been used for powering up the relay module. And let me show you the cloud server, the cloud IoT cloud dashboard that I've designed on Arduino's IoT cloud. Here is the unlock button, pressing on which you can simply unlock the door. Here is the bell icon that will be blinking once a person is present at the door, and here is the door state, which will be red if there is if the door is locked, and will be green if the door is unlocked. And there is a stat chart over here that will be showing you at which time the door was locked and it was unlocked, at which time the door was unlocked, to be more specific, I should say. And you can also take access to this IoT dashboard from your Android application. I'll show that once I'll be switching on the video stream. So that's all about the components that I've used here. I will communicate, as I've already told you, that I'll be running the Python script for detecting the face on my laptop, and the hardwares are controlled by the ESP32 board. So there must be communication between Python on my laptop and the ESP32 board, and I'll be following serial communication to establish communication between the ESP32 board and the Python kernel of my laptop. So in this way we can easily exchange two-way data. In other way, we can also exchange data between the ESP32 and the laptop indirectly by using a local server generated by the ESP32 board. But for this part of the project, I really don't need to use any local servers. So I believe I'm done with the description of the components. So with all done, I would like to directly dive into the demonstration right now, the way the project works. So before diving into the demonstration, I would like to ensure that I've plugged in all of my devices. So let's see, let me power on the relay module, let me power on the bulb, and yes, I've powered on everything, so I'm ready to run the code. So let's run the code and see what happens. Okay, the serial device must be available very shortly. Let me ensure that the Wi-Fi is turned on. Yes, it is. Well, I've started my kernel after a good while, so it's taking some time to load the program. So I have to wait a bit as long as the code isn't executed. So let's wait a while. So it took around 1.5 minutes to run the code. It took a good while. I don't know why. Usually it doesn't take this much of time to start the kernel. However, that's not a big deal. As you can see, I'm a bit inclined. That's because of the fact that I want to be out of the virtual zone initially for demonstration purpose. So on the top left corner, as you can see, I have the FPS, or the frame per second, that will be telling us if the operation, if the process is affecting the frame per second, if it is affecting the frame per second. And you can see it's telling me scan your face. So if my face is within this virtual zone, then it will detect my face, and it means that someone is present at the door, because it doesn't require to search for the entire frame. There might be someone mistakenly standing in front of your door, but the person doesn't really want to enter your home. He's not interested to get in there. So in such cases, to avoid such kind of scenarios, I have drawn a virtual zone, and the detection will only work if a person is present, if the face of a person is present within the virtual zone. And as you can see that I've already been prompted, scan your face. So as I will get my face within this virtual zone, the alert will be triggered. As you can see, I believe you can see this red bulb. The red bulb will start flashing, and I believe you can see the door lock. Let me see if it is clear enough. Yes, it should be clear enough. Here is my door lock. I believe you can see this. So it will be unlocked, provided that I unlock it from either the IoT cloud server, as you can see it from here, or by pressing on this touchpad, as I've already shown you during the component description, or I can also unlock the door using my cell phone. The cloud dashboard is loading on my Android application. So let's wait a bit. Yeah, it's been completely loaded. As you can see that I have a dashboard over here from where I can also unlock the door. It's a replica of the web dashboard that I've recently shown you. And the information will be immediately transferred to the corresponding person on Telegram via Telegram alert. I'm going to show you that very shortly. So let's dive into a demonstration right now and see what happens. So as my face will be within the virtual zone, the red bulb will start flashing along with the buzzer, and then let's see what happens. You see it's telling me check door, and it will stuck for 1 or 2 seconds, because in between this time it mainly sends the Telegram alert. And I'm going to show you that at 11:40, I believe you can see 12:40, the Telegram alert was sent to me with the photo, with my photo. I believe you can see that quite clearly. So the alert has been sent to me that someone is at my door, and the face has also been sent to me on Telegram. So it's a good feature. The alert immediately gets sent to Telegram. As you can see, it's available on my Telegram. I can show you. I had to take access to a Telegram bot via using an API. As you can see, it's named as doorbell. Maybe it's not that much clear because of the low resolution of my webcam. As you can see, the alert has been sent to Telegram, and the time is 11:41 right now. I mean, the alert was sent just now. And if a person was present or not, whoever was the person who rang the bell, who was standing at the door, the image of the person will also be saved locally. I believe you can see this. You can see this image while I was checking my phone that was captured. These are the older images. You can see this image has been captured and saved to my local device. So whoever is knocking at the door, whoever is entering the door or ringing the doorbell, all this information will be saved in your local device as well sent to Telegram. Now, after observing Telegram, you may want to lock the door or unlock the door. So let's say that let's demonstrate that for one more time. Yes, I'm within the virtual zone. A message has been sent to me on Telegram. I have already received a notification. Now say I want to unlock the door. So what I'll do, either I can press on this touchpad, or I can also unlock it from the IoT cloud dashboard, like simply by pressing here. And you can see the IoT cloud dashboard that bell is flashing, door state is red. So right now I'm going to unlock it. Okay, I forgot to plug in the battery. I'm so sorry about that. So let's start from the beginning. Yeah, so it's telling me check the door. Yes, the alert will be sent to Telegram, and the time that it takes to send the alert to Telegram, it lags for a while, like 1 or 2 seconds. The time that it takes for it to send the alert to Telegram. So right now, say I want to unlock the door. So what I have to do simply press on this button. Let's see what happens. You see, the lock has been unlocked. The lock was unlocked. So let me try to unlock it from my cell phone and see what happens. See if it works. So let me load the cloud dashboard from my cell phone. I'm trying to load the cloud dashboard from my cell phone, and say I would want to unlock it from the cloud. So what I'll do simply, I believe you can see, I'm going to click on this button. I don't know if that is visible enough. So let me click here. Well, it's lagging a bit because of the slow internet connection. Yes, as you can see that the lock was unlocked. Maybe it lagged a while because of my low resolution camera. I apologize for that. So let me unlock for one more time from the cloud. Clicking on the unlock button, you see the lock has been unlocked. Maybe the video lags a bit during that time. I apologize about that. And if you want to, then you can also unlock the door by simply pressing on this touchpad. So let's press on this touchpad. You see the lock has been unlocked and locked again. So if you're out of the virtual zone, that means you're away from the door, you have entered the room or whatsoever, and the alarm has gone off as well, as you can see. So let me get into the virtual zone once again. I have been sent an alert on Telegram. If you want, you can unlock the door or keep it the way it is. And if a person gets away right now, then that will be logged as the lock state. That means someone was present but the door was not unlocked. I'll show that in the Excel file shortly. So let's get out of the door. That means in our case, let's get out of the virtual zone. So I'm out of the virtual zone. Now I'm getting into the virtual zone once again. The alert as usual will be sent to me via Telegram, and it lags a while for 1 or 2 seconds, which is the duration it takes to upload the file to Telegram. And let's try to check the dashboard. Yes, it's updating continuously. You can see the chart in live way, 1 hour interval, 1 day interval, or 7 day interval. So let's try to unlock it from the cloud server once again. Let's click in here. You see the lock has been unlocked. It lags a bit, it lags a while because I'm recording the video with my laptop's webcam. That's why it lags a bit when the door is unlocked, because during that time the code holds for 3 seconds. The Arduino code holds for 3 seconds. It keeps the unlock state for 3 seconds, and after 3 seconds it locks again. And during this time there is no communication between the ESP32 board. Maybe I said Arduino, it should be ESP32, between the ESP32 board and the laptop. And this is the reason, due to the lack of communication, the video feed freezes for a while, and that's why you see when the lock is getting unlocked, the video is freezing for a fraction of seconds, I should say. So that's how it works. I believe you can see that the alert is flashing due to the lag of my webcam. That might not be that much visible, but it is blinking for 2 times. It blinks for 2 times on each of the signals transmitter from the Python script. So that's how this project works. As I'm out of the virtual zone, you can see it's telling me to scan my Face ID once again. So this one, the last one, should be my lock state, and the previous one was my the last one was my unlock state, and the previous one was the lock state, I should say. So that's all about the demonstration of my project. So let's get in here and exit with the lock state. So that's all about the project. I hope you liked it. Right now I'll be showing you the logs, the Excel log. But before that, I would like to stop running the code, because I believe that I'm quite done with the with the live demonstration, I should say. So I'm exiting the video feed right now, exiting the code right now. Yes, I'm done. The alert has also gone off, and I'm going to show you the Excel file. So doorbell log, the last state should be the lock state. As you can see, the lock state, the unlock state, and the lock state as we expected. And it's showing us the logs with the numbers, which I mean the chronological order, like the second doorbell, the third doorbell. You can also sort them date wise. You can see the date over here. You can see the time when the doorbell, when someone was present at the door, and the state of the door lock, whether the presence of the person, whether in presence of the person the door was unlocked or it was kept locked. So of course it will play a significant role in case of smart security systems. As you can see, we have a real-time database. We are saving the image of the person who is entering, who is at the doorbell locally, as well sending it via Telegram. So even if you are not at home, you can anytime check who the person was at the door, and you can even if you are not present at your home, you can unlock the door on basis after verifying if you want that person to enter remotely from any part of the world. So that's the best part of this project. Maybe it was a bit lengthy, maybe the video was a bit lengthy. I apologize for that. So that's all about this project. I will be deploying the same thing on Raspberry Pi shortly. In that case, I will be able to do the entire thing on a single board, on a single Raspberry Pi with no ESP32. So that's all for now. Thanks for watching. Stay tuned for the next one. Bye for now.